Hello again everyone, this is Jordan from ROBOTIS Inc. And today we're in the last episode of the ROBOTIS Premium series. In this episode we'll be covering the third and last level for the ROBOTIS Premium kit, which is the advanced level. In this kit, or in this video, I will be demonstrating one particular build, the Humanoid Type A, which is one of the most, if not the most difficult builds for the kit. The reason for this is because it uses majority of the plastic passive pieces as well as all 18 Dynamixels that we provide you in the kit. In this episode, we will be covering the basic tips and strategies of how to assemble this robot. After that, we will cover the default program for this robot that we provide you in RoboPlus Task and Motion. But prior to this video and going on, you need to have reviewed already the previous episodes so that you can have a foundation of how to build a robot, how to program using Task 2.0, as well as how to choreograph the certain motions in R+ Motion. Let's get started. Alright everyone, so as I said, this is the Humanoid Type A build. He uses all the 18 Dynamixels, which really complicates him, and yet, thankfully, I am going to show you some of the key tips to keep in mind while assembling him. One of the first is what I'm going to start off with is the ID map that I have right here, as well as the horn orientation that you need to keep in mind. So as I said, all 18 Dynamixels are used in this robot. So what you need to keep in mind is when he is in full configuration, as you see in the map, and you extend him fully, as you see right here, he should have all his torso. Sorry, I'll put him right here. You should see all his Dynamixels even on one side, on his right side, and his left side should be all odd number Dynamixels. What to keep in mind also is that when you have him fully extended like this, as you see in the ID map, is the horn orientation. What I mean by horn orientation is, as you can see on top of this Dynamixel, there is a little tick mark for on the casing and on this little wheel here. This wheel is called the horn, and what you need to keep in mind when you're assembling the when you're assembling the humanoid is where this horn orientation really is. Is it at 12 o'clock, which is going straight up, facing the tick mark, or is it at 3 o'clock, which you could see right here, or I don't know if you could see it that well, or is it at 6 o'clock all the way down here, or is it somewhere else? So what you need to do is look at the orientation of every single ID of the Dynamixel that you're using or that you're assembling with at that point in time, and see what orientation the Dynamixel is in. Is it supposed to be at 12, or is it supposed to be such as ID 7, or for ID 7 and 8? Is it at 10 or 2 o'clock? Which you could see is this one is supposed to be at 10 o'clock. This one is supposed to be at 2 o'clock, which is pretty much diagonal to where the screws are. For the others, such as the legs and the top and the torso, even the arms, including the arms, are supposed to be all at 12 o'clock position. So so while you're assembling, keep that in mind. Go to this, refer to this ID and horn orientation map, which I have provided in the link below. Now that we have covered the fundamentals of how to construct the humanoid build, now I'll be going over the default program that we have provided to you in task and motion. I'm going to go on and assume that you have already gone through the steps or the previous episodes of knowing how to download these programs for the Humanoid Type A. In this default program that we provide you, we have 4 types of modes to show off the Humanoid Type A build. The first is the self-test mode, second is the demonstration mode, third the autonomous mode, and fourth, the RC or remote control mode. So what we're going to do now is show off the default program for the Type A build. Since we have already gone over some example programs for the beginner and intermediate level, I'm going to just assume that you have downloaded both the task and motion files for this robot from the programs. So all we're going to do now is show off the 4 modes, starting with the self-test mode from the default program. Let's turn them on and make sure that the play LED is on. Push start, and he should go into his ready stance. He's kind of wobbly sometimes when you first start him, but it's not to be worried. So when you first start him, make sure that he is standing properly, as you can see here. But let's go and go into or select self-test mode. So let's press U, and it always starts off at ID 1, which from the map here, and also which you can download in the description below, you can see that ID 1 is here. So if you look in the top hole on the top, you will be able to see a red LED lit on ID 1. If you press up again, you will see ID 2 lit up. And if you push up again, ID 3 will light up, which I don't know if you can see in here, but you press it again, ID 4 will light up, ID 5 will light up. Yeah, it's kind of hard to see, but if you keep pushing, ID 6, ID 7, and he will also make sure that he is orientated correctly. I'll move that one right there, and you see that that's a proper response. You can see the LED in there. So that means that he's okay there. So let's keep going. ID 6. Yep, there it is. So you just keep pushing up, making sure that all the LEDs on the Dynamixels are recognized and they're lit up. If they do light up, that means that they are all properly connected and they are communicating with each other, which is exactly what we want. So now that we have tested the build by using self-test mode, let's go into demonstration mode. I turned him off, so let's just turn him right back on. Press start. Make sure he doesn't fall over. There you go. And let's press D for demo. Great. So through this demonstration mode, he actually will be using majority of his motion files. So let's put our hand right in front of him, and he will bow. This tests out the DMS sensor, or the distance measuring sensor. Let's clap. And the mic on the controller, CM530, actually recognizes the claps. This is demonstrated from the previous episodes. And then he will go into other motion files, such as scratching his head. Then the next one, he will do a gorilla pound on his chest, and then he will do a push-up and then a headstand. Now, what's really important about this demonstration mode is that it actually tests out your the screws to see if they are properly tightened. If they are not, then the robot may actually malfunction and fall apart, and that gives you an indication of what you have to do to make sure that you have a secure build. He's a little bit of a show off in this mode, but pretty cool nevertheless. So that was demonstration mode. So now that we have both demonstrated the demonstration and self-test mode, now we'll continue into the autonomous walking. All you have to do is turn it on and press start when the red LED is on or the play mode is on. He'll stand up, make sure that he doesn't fall over, and press L, which is left. And what he does is simply walks forward by default until he senses some kind of obstruction. I'm going to turn him around. I'm going to put my hand in front. I'm going to get him again. Put my hand in front. Keep my hand in front of him until he starts walking the other way. So as you can see, he just keeps walking. Now, keep in mind that I don't have any other sensors on him. So the only sensor that he goes by is the DMS, or the distance measuring sensor. He could have other sensors if you would like, just by adding one of the IR sensors maybe to maybe his thigh or up here maybe. Depends on what you want. But as of right now, the default program only has the DMS programmed because that's the only sensor that this build is using. Now we will go over the fourth and last mode of the default program, which is remote control mode. In this mode, there are three options that you could do. One, PC, which is by the USB port on the controller where my thumb is, or you can have them be controlled by the Zigbee, which is similar to what we've done in previous mode or in previous examples. The third example, or the third way that you can remote control this humanoid, is by Bluetooth, which is what I mentioned before, by this guy right here. You can purchase this module from our shop website in the description below. This is the BT210. This is compatible with PC and Android devices. For those Apple users or iOS devices, you will need to purchase the BT410. So let's turn him on and press start. Now that he is ready, I'm going to press right, and now he is in remote control mode. Now that he is in remote control mode, let's go to our smartphone, which I'm using the Android smartphone here, and open up R+ Task as you can see here. When it opens, you need to pair your device. Mine is the E6 module, so I'm going to select it and press OK. When you have selected your Bluetooth module, go and select remote control. Automatically, the robot is automatically detecting that there is a device connected to it. So let's have him go forward. Let's have him go backwards.
Have him go forwards a little bit more. Then immediately go backward. Oh, have him go backwards. Oh, he fell down. But that's not a problem. Simply push 1 and down. Oh, 1 and down. Now let's have him attack to the right. There are several other actions that you can have them do in the app here just by looking at the manual, and that is provided in your kit.
And with that, we have successfully been able to cover all 3 steps in the ROBOTIS Premium kit. You have learned all the fundamentals that we are able to provide for you, and you are able to create your own builds for this kit. Please provide us those ideas on our Facebook and YouTube channel in the description below. Until then, have fun and stay creative.